Howdy, howdy, this is Mr. Potter. Today we're going to be going over the 2018 AP Computer Science A free response questions. So might as well get into it. So, problem 1 says the question involves reasoning about a simulation of a frog hopping in a straight line. The frog attempts to hop to a goal with a specified number of hops. The simulation is encapsulated in the following frog simulation class, and we'll write two of these methods. We're going to end up writing the simulate method here, and we're going to be writing the run simulations method here. So let's talk about what's happening here. For the simulation method, we're going to be starting at a position of 0 within a maximum number of hops. We want to return true if we reach our goal within the maximum number of hops. Otherwise, we're going to return false. So if we exceed our goal, then we're good. It's just that if we end up falling short of our goal, then of course we're going to return false. We have a method called hop distance that we're going to call repeatedly, and as we call it repeatedly, we're going to be getting different values out of it. It's going to be the number of, or the distance that we hop each iteration. A positive distance moves towards the goal, a negative distance moves away from the goal. The distance varies from call to call. Each time the frog hops, its position is adjusted by that value. And we are going to keep going until three things happen. So 1, the frog has reached or passed its goal. 2, the frog has reached the negative position. Or 3, the frog has taken the maximum number of hops without reaching the goal. So in other words, we're going to keep going unless one of these three things happens, and we should get a true or a false when this is completed. The following example shows a declaration of a frog simulation object for which the goal distance is 24 inches and the maximum number of hops is 5. So here, notice I've got 5, add 7 makes 12, take away 2 makes 10, 10 and 8 is 18, 18 and 6 is 24. We reach our goal, we return true. Here we have 6 plus 7 is 13, plus 6 is 21, plus 6 is 19, plus 6 is 25, which gives us true. Here we've got 6, take away 6 is 0, plus 31 is 31, which is also true. Here we get 4, then 2, then a minus 8. As soon as we hit this minus 8, notice our total went from a 4 to a 6 to a negative 2, so we stop hopping and we return false. Here, the maximum number of hops we get is 5, so 5 and 4 is 9, and 2 is 11, and 4 is 15, and 3 is 18. We don't reach our target of 24 within time, we return false. So we are going to keep going as long as we're not negative, we still have hops to do, and we haven't reached our goal. And as soon as any of these things happen, we're going to return true or false. All right, so let's talk about what's happening here. First thing is I have to return a value at the end. I'm going to have to be returning something of type Boolean. So I'm going to start by keeping track of my position. My frog is going to be starting at position 0, and we're going to be adding or subtracting to it based on this condition. And then we're going to go up to our maximum number of hops. So I'm going to set up a loop, a for loop. Int hop gets 0. Hop is going to be less than the max hops, which is the constant we have. Hops plus plus. And inside this loop, we're going to have to check a couple of things. The first thing I'm going to do is I'm going to get hop distance and add that to position. So I'm going to say that pause is going to get pause plus hop distance. And remember, the things that are going to stop us is 1, have we reached the maximum number of hops? If we haven't, we're going to continue in the loop. 2, if we've reached our target. So if my position is greater than or equal to hop distance, not hop distance, the goal distance, if that's true, then I want to return true. Because I've reached the goal, I'm good. If position is less than 0, then we've gone negative. Remember, that's the thing that actually can stop things as well, so we return false. But if neither of these things happen, then we're going to keep going until we've done all of our maximum hops. Now, if we reach this point, if we've exited our for loop, then we haven't reached our goal distance. So we're going to return false at this point. And that's the end of our method. So notice what's happening here. I'm starting my count at 0, and I'm going to keep going until I've reached my goal distance, and that's a good situation. Or I go backwards, I end up with a negative position, and that's a bad situation. Or I've reached the maximum number of hops. If I reach the maximum number of hops, that means I haven't reached my goal, and that's a bad outcome, which is why I'm returning false here. So that's what I'm looking at for part A. On part B, it says write the run simulations method, which performs a given number of simulations and returns the proportion of simulations for which the frog successfully reached or passed the goal. For example, if the parameter passed the run simulations is 400, and 100 of these 400's simulate method calls return true, then run simulations method should return 0.25. So in other words, we should be getting a double out of this. Complete run simulations below assume that simulate works as specified regardless of what you wrote in part A. Remember that simulate is going to return true or false depending on whether or not we made it. So I'm going to have to make sure that I go through this a certain number of times, num number of times. And I'm going to start off by declaring a double called successes. And I'm going to start that at 0. And then I'm going to go through and I'm going to run for each of these things. So int run is 0, run is less than num, run plus plus. This is keeping track of how many of these runs I've done. This is the number of simulations that I've run so far. And then if simulate, keep in mind that simulate is a Boolean function. It's going to return either a true or false. If I get a true out of it, then I want to successes plus plus. In other words, I've got a good true out of it. I want to add to my successes. If I don't get a good out of this, then I don't want to change the number of successes. It's just going to be a failed run, and I'm just going to increment my run counter. And then at the end, I want to return that fraction. Remember, I need to return 100 out of 400 to get that 0.25. So I want to return successes divided by num, because num is the number of simulations that I'm trying to run here. Here I'm really doing 100 divided by 400, and because this is a double, that ensures that my answer is going to be a decimal 0.25. So we're good. So that's part B, and that completes problem 1. On problem 2, it says this question involves reasoning about pairs of words that are represented by the following word pair class. So I'm going to have a class that has first and second word pair, and I'm going to have accessors for the first and second word. And then I'm going to implement the constructor and another method for this word pair list class. Keep in mind that we have an array list of word pairs. We're going to have a constructor that we're going to have to write, which is going to give us a list of words, and we're going to have to populate this array list. And then we're also going to have to write the num matches method. So keep in mind that I'm going to be given an array of words, and I'm going to have to make all possible combinations. So I'm going to have 1 with 2, I'm going to have 1 with 3, and I'm going to have 2 with 3. So I'm going to have to go through this array with an I and a J. And as long as I and J aren't the same, then I'm going to create a word pair and add it to my list. So here I'm going to have the with more. I'm going to have the with the. Keep in mind these thes are different because they're different elements in the array, even though they're the same literal value. The with merrier, and that's the with all the words. Now I have more with the and more with merrier, and then I have the with merrier. And that's how they're getting these values here. So I'm going to have an I and a J. I'm going to have nested loops that are going to go through, and then it's going to create a word object, and it's going to add it to the list. That's the process that we're going to be doing here. So we have to write our constructor. So for our constructor, I need to make sure that I have an array list. So I'm going to construct all pairs, and that's going to be a new array list of type word pairs. And then I'm going to do my nested loop. So I'm going to do for int I gets 0. I has got to be less than the length of words. I plus plus. And then I'm going to have another loop here. Int j as my other loop control variable. But I don't want them to be the same, so I'm going to say j is going to start at I plus 1. J has to be less than words.length, j plus plus. And then in here, I'm going to create a word pair object and add it to this list. So I'm going to say all pairs dot add, and I'm going to create a new word pair. And for the word pair, I'm going to take the elements of words at position I and at position j. This is going to be words sub I and words sub j. Close parentheses for the constructor, close parentheses for the add, and semicolon. And that's all that we need here. That's going to be all that we need for the constructor, because that's going to initialize all pairs, and it's going to do every single pair of distinct words. So on to part B. Part B says once we have all of these pairs populated, now we need to figure out how many matches we have. So we're going to have to go through that array list of all pairs, and we're going to have to look for all the ones where the first word and the second word match. So notice here the and the match, here red and red match. So that's what we're going to have to do. Obviously, we're going to have to keep track of how many of these we have. So I'm going to say int count gets 0. And then I want to go through everything in all pairs. Well, I have no idea how many things are in there, so I'm going to use a for each loop. So I'm going to say for each word pair, which I'm going to call pair, in all pairs. And for each one of these word pairs, I want to say if pair dot get first dot equals, keep in mind these are string objects, so I need to use the dot equals. I can't use equals equals. And in here I'm going to have pair dot get second. Close for get second, close for equals, close for the if statement. If that's true, then I want to count plus plus. And then once I'm done, I need to make sure that I return that integer, so I want to return count. And that's problem 2. It's very straightforward, just going through the array list, pulling out each pair using the for each loop, and then making sure that the first and the seconds match using the dot equals method. All right, so for problem 3, we have our string checker interface. This describes the classes that check if strings are valid according to some criterion. In order to implement this interface, we need to make sure that we have some method called isValid that accepts a string and returns a Boolean. And we're going to create a class called CodeWordChecker that's going to be checking these strings based on some parameters. And I actually am going to have 2 different constructors. I'll have one constructor that has 2 integers and a string. And then I'm also going to have another constructor that's just going to have a string, and in that case, I'm going to be defaulting the minimum and maximum lengths to 6 and 20 instead of explicitly describing them as we did here. So let's go through a couple of examples. Here, I'm given the low and the high, and this is the bad string. This is the thing I don't want. So anything that's between 5 and 8 characters inclusive is perfectly fine as long as it doesn't have this dollar sign. So notice happy is 5 characters, that's fine. Happy with a dollar sign, that's not good because it has the bad character. So that's false. Code is too short. It's only 4 characters long. It's less than the 5 we specified. So that's going to be bad. And happy code is too long. That's the 9, which is too long for us. So that's going to be bad as well. Now, I also have the other constructor that only has a string. And in this situation, my low is going to be 6 and my high is going to be 20. So anything between 6 and 20 characters inclusive is fine, as long as I don't have lowercase p, lowercase a, lowercase s, lowercase s. So here in my pass, this is perfectly fine because it is 6 units in length, and I have capital P instead of lowercase p. It doesn't exactly match, so we're fine. This is good. Here, this PASS exactly matches, and that's why it's bad, even though it's between 6 and 20 characters in length. Happy's too short. It's only 5 characters in length, so that's bad. And one millions, billions, trillions. Yeah, 1 quadrillion, well, that's too long because that's 4, 8, 12, 16, 21 characters. 1 character too long, darn. So when we're writing this class, we need to make sure, number 1, that we implement this interface. We need to make sure we have a method called isValid. And we need to make sure that we have one of each of these constructors. And because of this, I'm going to need to keep track of these 2 integers, whether they're given to us or whether they're our default values. And I'm going to have to keep track of this string. So I'm going to have some private variables in this class as well. So it's going to be a pretty complicated class. So let's go ahead and write it. So I'm going to say public class code word checker implements string checker. Now, for our purposes, we're going to have 2 private ints, which I'm going to call low and high. And I'm going to have a private string, which I'm going to call bad. And then I'm going to have 2 constructors. One constructor, public code word checker. I'm going to have an int low, int high, and int bad. And so what happens is my constructor, the purpose of it is to fill in these instance variables. So I'm going to say that low is going to get low, high is going to get high, and bad is going to get bad. And that's that constructor. All that I'm doing is I'm assigning my parameters to my instance variables. I also have to have the constructor code word checker with just a string. And in this case, we're going to assign low as 6. We're going to say high is 20. And we're going to say that bad is going to get bad. All right, so the only thing I have left to do is I actually need to implement string checker, which means I need to write a Boolean function called isValid, which is passing a string called str. And I'm going to go through and check str. If it's too short, I'm going to have to kick out a false. If it's too long, I'm going to have to kick out a false. If it has anything in this, if it has this bad string in it, I'm going to have to kick out a false. Otherwise, I'm going to return true. So, first thing I'm going to have to do is check if str.length is less than low, then I want to return false. If str.length is greater than high, then I want to return false. And if str.index of bad is not equal to -1. Remember that -1 is what I get if it doesn't show up anywhere. So if I don't get a -1, I know that it did show up somewhere. If that's true, then I want to return false. Now, if I made it through all three of these lines, then I'm good. And so at this point, I'm going to return true. And we're good. Notice that I've got the instance variables to keep track of length. I've got the instance variable to keep track of what's a bad string that I don't want to have. I have both constructors, one where the constants are given to me for length, one where I have to use the default of 6 and 20. And then I check for all three conditions. If I'm too short, if I'm too long, or if I contain bad text. So that's problem 3. And on to problem 4. This question involves reasoning about an arrays of integers. You will write 2 static methods, both of which are in a class named array tester. So I'm going to have array tester and I'm going to have static methods, one called getColumn and one called hasAllValues. I'm going to write this one and I'm not going to write this one. And then over here I've got contains duplicates, and then I want to know, is it a Latin? And so I'm going to have some square that I'm going to have to check in part B. First thing I want to do is write a static method called getColumn, which produces a one-dimensional array containing the elements of a single column of a two-dimensional array. In other words, if I give it a 1, I want everything that's in column 1, but I want to make it an array. So I want to get 1, 4, 7, 5 out of it. And so this is our non-traditional traversal of a matrix. Instead of going row by row, incrementing the rows, then incrementing the columns, I actually want to stay in the same column and just increment the row, going down in order. So, skipped a page. So I need to write this method here. So let's talk about what that method would look like. So I've got public static, and this is going to return an array of int, which I'm going to call getColumn. And I'm going to pass it a two-dimensional array called array2d. And then I'm also going to pass it which column number I want. So the first thing I need to do is, because I'm returning an integer array, I actually need to create an integer array. So I'm going to say int array call is going to be a new integer array. And the size is actually going to be determined by how many rows this array had. So I'm going to need to look at array2d dot size. So the size is going to tell me how many rows this is. This is how many elements this column is going to have. And then I need to go through this array and take those elements out. So for int r gets 0, r is going to be less than array2d dot size, r plus plus. So this is keeping track of the row. This row is going to be the first element in column, row 0. The next row, row 1, is going to be the next element in column. So in here, I'm going to say that column sub r is going to get whatever's in array2d in row r and column c. Notice that column C never changes. It's always the same. Column C in our example is always 1, so I want what's in position 0, 1. Then I want what's in 1, 1. Then I want what's in 2, 1. Then I want what's in 3, 1. So that's always going to be the same. I've iterated through my loop, and then I'm going to return that one-dimensional array column. So that's part A. It's pretty simple. It's a non-traditional traversal like we've done several times in this class. The next thing that we're going to be looking at is the isLatin, which is going to check to see if we've got a two-dimensional square array that is a Latin square, and otherwise we're going to get false. So in other words, I need to make sure that this first row has no duplicate values. If there's any duplications, that's bad. And then I need to make sure everything in the first row shows in every other row. So this 1, 2, 3, I've got a 1 and a 2 and a 3. It shows up in that row. And then I've got a 1 and a 2 and a 3, and it shows up in that row. And then everything in this row also has to show up in this column. So I have to have a 1 and a 2 and a 3. I have to have a 1 and a 2 and a 3. I have to have a 1 and a 2 and a 3. So I'm going to have to go through and make sure that everything in the first row appears in every row, and everything in the first row also appears in every column. If any of these mess up, if one thing is bad, then I'm false. So I can just return false at that point, just kind of wash my hands, make the program stop. Now, what's nice is that I have some tools at my disposal. I have a function called hasAllValues. And what that's going to do is make sure that the array that I'm looking at has all values. I can assume that it's working. Similarly, I have contains duplicates, which allows me to make sure that there are no duplicates in there. And then I've got getColumn, which we wrote, which actually gets everything in there. But even if I made a mistake in part A, I get to assume it works here, which is really, really nice. So what I'm going to do is I need to first keep track of my first row. And that's going to be equal to square sub 0. And this first row is the one I'm going to be comparing with everything else, but I need to make sure that there are no duplicates in it, because if there's any duplicates in it, it can't be a Latin square. So if contains duplicates, first row. If that's true, then I want to return false. There's no reason to check anything else because I know that I've got a false at this point. If I make it past this line, I know that my first row is good, and so now I can compare it to every other row. So I'm going to create a variable called size, and this is going to be equal to square dot size. Now the thing is, I know that this is a square matrix, so however many rows I have is exactly the same as the number of columns, and that means size is actually going to be the boundary for my loop control variable. It's going to be the last thing that I check. And now I need to check each row. So for int I, or r, let's use r gets 1. R is less than size, R plus plus. And I know you're saying, why aren't we starting at 0? We usually start our rows at 0. But keep in mind, my first row is row 0, and I've already taken care of it. So I don't need to start with row 0. I want to start with row 1 and make sure row 1 and every other row that follows it is good. So if, and I'm going to check to see, first, does it contain any duplicates? Because if it contains any duplicates, I'm going to kick it out. So if contains duplicates, and I'm looking at square sub r, or, because I can not contain duplicates, then now I'm going to actually check, do I have all the values? So I'm going to check not has all values, because I want to find out if it's a bad row. I want to see if it doesn't have all the values that first row has. So I'm going to compare first row with square sub r. And if either of these are true, then I want to return false. And that's going to get me through this loop. So once I've completed this loop, I know that every row is good. So now I need to check the columns. So now I'm going to say for int c is 0, c is less than size, c++. So now I'm going to go through every column of square, but I actually need to check column 0 because I haven't checked it before. I started at 1 up here because I had checked the first row. And I'm going to go through each one of these and I'm going to get that column. So I'm going to say int array call is going to be equal to my method getColumn that I assume works. So I'm going to say getColumn for whatever C happens to be. And then I'm going to test, and I'm going to test exactly the same way as I did here. But instead of checking my row, I now want to check call. So if contains duplicates call or not has all values, and I'm checking my first row with call. And if I make it into this if statement, then that's bad, and I want to return false. Now, if I make it out of this loop, that means I've checked all the rows here, and I've checked all the columns here. So everything's good, and I'm going to return true. So this was kind of an ugly end to our free response, but again, we get to assume that all of these pieces work nice, and we just have to make these pieces work in the right order. Other than that, I thought that these were a very straightforward free response. I didn't see any surprises on here. Everything seemed to be a lot like the exemplar labs, like the 11s reminded me a lot of the frog game. Looking at the way that we dealt with our magpie, how we manipulated strings, I saw a little bit of that when we were dealing with our word pairs, making sure everything's in there with an array list. I saw a lot of similarities to the programs that we wrote in this year. Hope you did very well. Good luck in your future classes. Once again, this is Mr. Potter. Thank you for watching. Have a great day.